This conference will now be recorded.
Huh? Why?
Yeah, can you hear me, guys?
Yes.
Okay. Okay. So in last class, I have shown how to create a complete network from console. That is in a manual way. Okay. So let us write the steps what we have done in last class, because same steps we are going to implement. Okay, from Terraform also we are going to automate the process. So as a first step, I did like create a VPC with a CADR 10.0.0.0/24. This is the first step we did. And the second step, create a internet gateway, get that gateway to the VPC. Create a subnet for public with a CADR 10.0.0.0/25. Create another subnet for private with a CADR 10.0.0.128 And as a simple step, create a route table for public subnet and associate with associate it with the gateway. and create another route table for private subnet. That's all. But we don't attach it with the gateway because that is the difference between public and private subnets. So as a 7th step, we are going to do like create a server. Server in the sense here, it is easy to instance. Easy to instance in public subnet. And before this, I have to do something like create a key file, okay, for the EC2 instance. As a 8th step, create a security group with 80 and 22 ports open. Okay, yeah, these are the 7 to 8 steps that we are going to perform here. And one more step, one more last step we have to do. This is 7, 8, this is 9th step. 9th. And log in into the server that is created in public subnet. Okay, this will be succeeded because there is a route from our system. Okay, so we are able to log in into the server. This is succeeded. And I am closing the comment. So comment in Terraform can be written by giving open by giving uh, forward slash and closing forward slash. Now let us start our work. And before that, let us activate credentials. To activate credentials, let us go to AWS console. And let us go to IAM section. And here go to users. And here this is 6th December, right? 6th December. And in the security credentials, access keys activate. And also go to our folder. I think where is that folder? It's 28 November. This one, 6th December. Here open git bash. From here open Visual Studio Code. Now let us take all these steps and copy these steps. Here in our folder, okay, create a file called vpc.tf. Okay, so you can write in individual files or otherwise you can write in single file also. Let us comment it because Terraform can consider only one file at a time. That is why comment it. And let us create one more file. This is vpc.tf. So just I am writing these comments. Okay, now let us start create a VPC with a CADR. Okay, now to create a VPC from Terraform, very easy. All you need to search is Terraform AWS VPC creation. And here there are so many examples are given here. Okay, so I told already, and every Terraform block will contain multiple blocks. Terraform script will contain multiple blocks, and one of the major block, one of the important block, one of the mandatory block is a resource block. So resource block tells what kind of resource you wanted to create. Okay, now this resource, and the resource type is AWS underscore VPC, and this main can be anything. You can write any name over here. This is for future reference purpose. And here CADR block. So with what CADR block you wanted to create your VPC. Okay, in our case that is 10.0.0/24. Here instance tenancy is not required here. Okay, and here tags. So under tags we can give, okay, any tag, any valid tag name. Okay, let us write this resource AWS underscore VPC. Name of the block is what? Our VPC. Our VPC. And what is the primary argument that you need to give? CADR block. CADR block. CADR block equal to within double quotes. Okay, are you seeing double quotes here? Within double quotes, you have to write 10.0.0.0/24. Okay. Why to take risk? Exactly, I will take this script and I will paste it over here because this is time consuming process. Here I am changing the name like our VPC, and the CADR block will be 10.0.0/24. Now instance tenancy is required, not required. This is how you can create a VPC, our VPC. VPC name will be our VPC. Okay, now here if you look at the arguments, here this is the argument list. CADR block instance tenancy. Okay, tenancy option for instances launched into the VPC. Default is default, which ensures that EC2 instance launched in the VPC uses the EC2 instance tenancy attributes. Okay, this is actually deprecated. No one is going to use. And once your VPC is created, okay, these outputs are generated. VPC ID, okay, and route table ID, default network ACL. These are the attributes that are generated. Okay, so as per our documentation, what is the next step here? Next step is we have to create a gateway. So to create a gateway, simply search like this: Terraform AWS Internet Gateway. It is also very simple, guys. Resource type is AWS underscore Internet Gateway. This is a gateway name, and VPC ID. So attaching and creation can be done in single step. Attaching and creation can be done in 2 steps, but sorry, 1 step here. But in console, first we created, then we associated. But here this is creation come association. Let us copy this. And what is the VPC name here? Okay, once gateway is created, we have to attach this gateway to the VPC. Okay, so for that we have to specify VPC ID. VPC ID equal to AWS underscore VPC dot main. So it is not main, it is our VPC. Our VPC dot ID. Gateway name is, you can give any name. This is my gateway. Okay, so this is gateway creation. Next thing is we have to create two subnets. One is public subnet, other one is private subnet. Okay. Now let us do it. Terraform AWS subnet creation. This is subnet creation, guys. Subnet creation block. Resource AWS underscore subnet is a resource type. Main is a resource, your subnet name. In which VPC you wanted to create. Okay, this is VPC ID. Okay, this is a CADR block. Let us do it. So this is what our VPC, right? Our VPC dot ID. And what is the CADR block here? 0./25. Okay, here I am giving as subnet 1. Subnet 1. And for this I am giving a name called public subnet. And in the same way, create one more subnet. This is for private use. Exactly, I am copying. So this is subnet 2. Subnet 2. And here the CADR block will be 128/25. And here this will be private subnet. Okay, two subnets will be created. Okay, our next task is we have to create two route tables. One route table for public subnet, another route table for private subnet. And let us search Terraform AWS route table creation. This is the route table creation block. This is the route table creation and attaching the route table to internet gateway. Okay, so in case of console we did it 2 times, but here in single step only we can do this one. Now let us do this activity. Take this script. Where I am going to call it as RT1, route table 1. And what is the VPC name? VPC ID is our VPC. And here we are not using route table, we are not using IP version 6, so we can delete it simply. And here CADR block, that means the route table, that means whatever traffic coming from subnet 1 must be redirected to internet gateway. Okay, that means any traffic. Okay, it can be any system. Okay, so that is why here we, in the place of CADR block, we are going to write 0.0.0.0/0. And what is the gateway name? Gateway name is GW. Here you are seeing this one, GW. Here this is GW. GW. And here this is, you can write it as public route table. In the same way, we have to create one more route table for a private subnet. So exactly I am taking this script. I am going to copy this. But this time we should not link it with the gateway. So we have to remove it. This is private route table. And this is RT2. Okay, now two route tables we have created. And we have to link up these route tables with subnets. So to link up these route tables with subnets, search the document. AWS route table association. Because this is association. So here in the place of association, I'm writing A1. And what is the subnet ID? This is subnet 1. And what is route table 1? Route table 1 is RT1, right? RT1 is for public subnet, RT2 for private subnet. So that is why I have given RT1.id, RT2.id. Okay, in the same way, copy once again. This is for second subnet association. So here I am going to give it as A2, and this is 2, and this is RT2. Okay, route table association is also over. So next thing is we have to create a security group. Okay, before that let us create a key file. Okay, now to create a key file, same thing here, Terraform AWS key file. Here this is key file. From console also we can create a key. Otherwise from here also we can create a key. Okay, so the resource type is AWS underscore key underscore pair, and the key name will be deployer, and key name you can write anything. Okay, here I am writing like key from Terraform. And now this is public key value. Public key value you have to give. Okay, how to give public value I will show. Before that, let us create security group. Let us go to again Terraform AWS security group. Okay, so in the previous class also we have created security group, right? Okay, this is exactly like that. And here we don't write outgoing rules. Egress means outgoing rules. We don't write this. And ingress means incoming rules. And here the resource type will be AWS underscore security underscore group. Okay, so here you can give any name, SG or test SG. Name description also optional. And here at the time of creating security group, we have to specify VPC name, VPC ID. So what is the VPC ID? Our VPC ID, our VPC, right? And this is incoming rule. I am writing 22 port number. Here also 22 port number is open. And here we are not using IP version 6, we are using IP version 4. So delete it. So here CADR block is, that means here for whom you are opening this port number, for everyone. So for everyone means this is 0.0.0.0.0.0./0. And we have to write one more ingress rule. Ingress description equal to you can write for 22 port. Here I am for 80 port. One port equal to 80, two port equal to so 80, and protocol will be TCP and CADR blocks will be for everyone 0.0.0/0. This is HG from Terraform. 11th December. You can give any name. Okay. And we have to create a key here. How to create a key? Creation of key is very simple. So it is will be created by using a simple command. That is this is Linux command SSH keygen. It is asking where to keep the key. Okay, so by default it is going to keep the key in the users username .ssh. This is a 519 is a key number. It is asking whether to overwrite or not. Yes, and go to that location. This is a location, right? C colon users username .ssh. The number will be 25519. Users, what is the location? Shivani. C users .ssh and 519. No, this is I think private key. Public key. Public key we have to import. Okay, exactly we have to copy this key. Okay, this is public and private key combination. Okay, we are keeping public private key with us and we are exporting public key to console. And here you need to upload this key. Okay, now let us validate the script. Almost we have created 6 or 7 resources. Say Terraform validate. Okay, it is telling that it is succeeded. Okay, now let us generate plan. Terraform plan. Validating credentials. What is this? Provider AWS. This is I think ES. What is this? Validating provider credential, retrieving caller. Let us initialize once again. I think, line number 11. US is to do correct only, right? What happened? AWS unclear. Terraform user 6th December. Okay. Why it is not validating? Okay, let us delete all the users. See what happens. Let us create another user. Terraform user. Give him admin access privilege. Let us give the values once again. Okay, now it is working. Previously there was a mismatching of credentials. Okay, that is why now it is telling that it is about to create 10 resources. Okay, so one VPC, two subnets, one internet gateway, two route tables, and one security group, one key file. Okay, this is a plan, okay, which it has to implement. Now to implement this plan, say Terraform apply -- auto output. Auto approve means it does not take any confirmation. Are you seeing in single shot? Are you able to create everything? Route table association, and if you want confirmation, let us go to AWS console, and here in VPC section, your VPCs. Are you seeing main VPCs created here? In subnets, two subnets are created, public subnet and private subnet. And route tables, two route tables, public route table and private route table. And gateway, one gateway is created, my gateway. Okay guys, is everything clear? Are you following?
Yes, sure.
Is everything okay, Shravani? Are you following? Okay, now let us create compute. Okay, we created almost everything, and here except virtual machine, we created everything. Now let us create a virtual machine in public subnet. Now to create a virtual machine, okay, so we have to give many inputs here. For that, let us search Terraform, AWS EC2 instance. Here, this is EC2 instance creation block. Resource AWS underscore instance name, and we have to give public ID, CEDR block. This is VPC network interface. You can take any one of this. Here, these are the arguments reference. AMI. Okay, AMI means what kind of AMI depends on uh, instance type. So AMI is a unique one and associate public IP address. So when I say associate public IP address to the virtual machine, public IP address is given so that from our network we are able to connect. And these are the CPU options, other argument references, host ID and instance type. The instance type generally here we are going to create T2 micro. Key name. What is the key name with which you wanted to create your virtual machine? These are the references. And when it comes to argument reference, argument reference, yeah, attribute reference, not argument. ARN and public IP address, public IP. These are the attributes. These are the outcomes when we create virtual machine. So these attributes are generated after we create a virtual machine. Now let us take this script. So here I am instance type I am giving as web server. Web server and instance type equal to T2 large, T2 micro. And these are not required. And public IP, associate public IP address equal to true. And the next subnet ID. Subnet ID. So what is the subnet ID? So when it comes to subnet ID, we have to take subnet ID of this one. is the subnet ID. So here in case subnet ID is of what type? Optional. Is dot. Next key name. Key name equal to what is the key value we have created just now? Key from Terraform, right? This one. AWS key pair dot deployer dot ID. Next we have to assign security group IDs. Here we have to write security group. So what is the security group ID? So this is our security group ID. Security group ID is a array type. Okay, so you can associate multiple security groups to the virtual machine. So here I am assigning only one group, one ID, dot ID. AMI we have to collect. So how to collect AMI I will show. Okay, here go to EC2 page. And click on launch instance, and here is just to come to here this place Ubuntu and this is the image ID. Copy this and paste it over here. AMI was given, instance type is given, associate public IP address equal to 2, subnet ID also given, and key name is also given, security group is also given. Let us validate this. Invalid and put after a dot. Also remove it. Here also SRG not ready. What is that? What is this? Let us remove this. Okay, now it is success. Um, Now let us apply the plan, Terraform plan. It creates only one. Okay, because already 10 resources are created in the previous step. Now just it has to create only one instance. So to create instance, say Terraform apply -- auto approve. Now it is creating server. Okay, one resource added. Now let us verify whether this is created or not. Let us go to instances. Cannot give any tags. Okay, I did not give any tags. So what is the ID here? 04C. 04C. Now can we connect to the server? Okay, if you want to connect to the server, click on connect. And let us paste this. Yes. Okay, are we inside the virtual machine? 10.0.0.0.5. Okay, now it has created a key file also. Now let us exit this. Say ls. ls-a. Okay, 10.0.0.0.5. Now let us see the IP address. The networking. Are you seeing private IP address? It has connected via private IP address. Okay, this is how you can complete automate. Okay, complete VPC process. Now whatever we did in last class, same activity. Okay, so were we able to do? Okay, but the thing is everything we have hard coded here. Like VPC CADR, subnet CADR, private CADR, and everything we have hard coded. Okay, but if I want to reuse the script for multiple environments, okay, I have to make something dynamic. So to make it something dynamic, okay, we are going to use variables here. So till this point, is everything clear?
Yes. Yeah.
Okay. And here, what are the things you can make dynamic here? Here everything like a CADR block we have mentioned over here. And here also we have written subnet 1, subnet 2. Now these are the values which might be changed from one environment to another environment. And suppose here port numbers are there, 22 port number and 80 port number. This might be changed from one network to another network. So we must be able to change these values dynamically. And let us say this CADR blocks. CADR blocks might be also be changed. So for that reason, here in the place of hard coded values, okay, we have to give values dynamically. So for that we are going to use something like variables. Now how to use variables and what are the types of variables that Terraform is going to support? Now let us see Terraform variables. And here these are the types of variables that Terraform is going to support, like string type, list type. Here these string type, number, boolean, list, set, map, object, tuple. Here these are the variable types that it is going to support. So a variable can be defined like this here. Variable, variable name, type, and variable name, a list of string, and default value. So default value means if you specify default value, it does not take anything from keyboard. Now we'll do one thing. We have created everything. Now what I will do, I will completely destroy the. If you want to destroy these resources, single shot, okay, you need not to go to any website directly from here. You can say destroy. Okay, completely 11 resources it has destroyed. Now let us go to this application. Let us comment completely. Okay, from here to here I will comment. And here I am going to define one more file called inputs.tf. So inputs.tf is a file where I am going to define variables. Okay, how to define variables? Now to define a variable, you can write variable name. Okay, here type equal to string. And what is the variable name here? Variable name will be VPC CADR. This is my first variable name. And the second variable, this is variable subnet. Okay. This is subnet CADRs. So here type equal to, I am going to write list of string. I don't write any default value. Okay, I am going to take subnet 1 value, subnet 2 value in the form of variables. So list means generally list is going to accept multiple values. And here one more variable also I am going to write. This is ports. This is also type equal to list of string. How is written link list? Variable name will be ports have written subnet CADRs, and I am also going to define one more variable, that is subnet underscore tags, type equal to list of string. One, two, three, four. And I am also going to define variable. Variable name will be ports are defined, subnet tags, subnet CADRs, and still what I have to define? Subnet underscore names. Is also list of, okay, type equal to list of string. And one more variable I will define. Variable subnet names are defined, and variable the value which might be changed during the runtime, okay, must be defined as a variable. From whom? This is type equal to string. I given 0.0./0, right? From whom? That value I am taking. Okay, these are the list of variables. How to use these variables in our script, Terraform script, that I am going to discuss in next class. Okay, so till this point is everything clear, right? If any questions are there, you can ask me. Otherwise, I will stop it for today and create from your side, create complete VPC. Complete VPC in the sense subnets, route tables, gateway, VPC, key file, security group, server. Okay. And tomorrow we will be using these variables. How to refer these variables in our Terraform script. Okay, we have defined variables, and once variables are defined, these variables must be referred from Terraform script, right? How to refer them from our Terraform script, that I am going to discuss in tomorrow's class. Okay. Is it okay, guys?
Yes, sure.
Planning for this.
Okay. So then I am stopping. Tomorrow we meet again. Okay. Thank you.
Thank you.